Hello, everyone, and thank you for joining us. My name is Gisela, and I will be the host for today's webinar, Case Systems Engineering Skills, Critical Thinking, and Problem Framing. Before I pass it over to our speakers, let me cover a few housekeeping items. At the bottom of your screen, you will find multiple application engagement tools. You can adjust their size and position to optimize your computer screen. To expand your presentation area or maximize it to full screen, simply click to the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical questions located in the Help widget at the bottom of your screen. Please note that a copy of today's slide deck and additional resources are available in the resources list. Please have a look and download everything that you may useful. Also, this webinar will be recorded and sent via the email you register with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We are here to answer you live via the chat throughout the presentation, so don't hesitate to reach out. In case we run out of time or we don't manage to answer your questions, we will make sure to follow up later by email. Now, I would like to introduce our speakers. Today, we are joined by Chris Unger, retired Chief Systems Engineer for GE Healthcare, has 40 years of experience in defense and medical systems engineering. He's a certified Master Black Belt, holds 15 issued patents with 2 pending, and is an INCO certified experienced systems engineering professional. Chris graduated from MIT with BS degrees in mathematics and philosophy and earns a PhD in physics from Boston University. He is the principal at PracticalSE LLC, a system engineering consulting company, and is actively involved in INCOS, where he is a member of the Chicagoland chapter, co-leader of INCOS Healthcare WG, and a co-founder of the Systems Engineering in Healthcare Conference. We are also joined by Vincent Balgos. He is the Director of Medical Device Solutions at Jama Software, bringing his extensive experience to the team for over 2 years. Before embarking on this role, Vincent spent a remarkable 17 years as a systems engineer in a medical device IVD industry, playing a pivotal role in a product development. He graduated with a dual BS in chemical engineering and medical chemistry for the University of Missouri-Columbia, and an MS in engineering and management from MIT, and is an INCOS member. His wealth of experience has made him a crucial contributor to shipping and improving Jama Software's solutions for medical devices. And with that, I will pass it over to Chris.
Thanks, Gisela. I appreciate it. So we're going to talk today about a follow-on to the last webinar, where I'm going to talk about some of the most important systems engineering skills, critical thinking, and problem framing. So how do skills in general and soft skills fit into improving systems engineering? So in prior talks, I've suggested to keep your processes very simple, but make them effective. And that's easy to say, but hard to do. That means you have to understand the system of the SE processes, how they connect, and where the diminishing value of the processes, the source process ending off happens. As an example, a topic could be a technical risk, or it could be a trade-off between different possible solutions. So we want to understand how those two, the risk management and the decision process, interact. And in order to do that, the best systems engineers have to have really good judgment. In addition, we have to influence people. Being simplistic, hardware and software engineers design things do what they're told. I know it's oversimplified, but our deliverable are instructions on how the software and hardware engineers do things. So the best systems engineers here have an area of depth that they're an expert in. So they bring some technical credibility. They have systems breadth. They understand all the systems processes and how they interact. And they have great interpersonal skills. And today I'm going to focus on how you achieve a balanced and optimized design, how you focus on your cost versus risk, and doing that through basically decision making. So first I want to talk about the Helix model. So the Helix project was a project funded by the government, US government, and their concern was for big aerospace and NASA projects, you tend to produce, a major, billion-dollar development every 10 years. And then you do 10 years of support. And so people often move on. So they were worried about how you create the truly brilliant leader systems engineers from a team that may be a little bit sparse. And they developed this model up here in the front. And simplistically was you start with things you learn in school. So how to do good mechanical engineering, electrical engineering, software engineering techniques. You then go into an organization. And so you spend the first 5 years learning about your company. So things like, well, if you're going to be doing a, say, glucose monitor, what does blood chemistry look like? What does a sensor look like? What's a workflow? So you become a good organization-specific mechanical engineer. Then you learn about life cycle. Like, okay, how do you go from womb to tomb, from customer needs to disposal and disposition with all the regulations across the world in terms of chemical safety. So after 5, maybe 10 years, you understand your domain, you understand life cycle, and you understand your technology. What differentiates after that? What they found was the skills on the bottom half of this page. The systems mindset, so big picture thinking, and paradoxical mindset. You've all heard that joke about, fast, good, and cheap, pick 2 of the 3. Well, that's the world in which systems engineers live. We make trade-offs between things that are inherently conflicting. The other thing is we got to make decisions quickly. So you got to have a flexible comfort zone. You've got to be willing to wait till you have the critical information, but make a decision without all the information you want. In terms of the middle column here, interpersonal skills, just the obvious stuff, as I mentioned. You've got to influence the other engineers to follow a good decision. And then finally here in technical leadership, balance decision-making and risk-taking. So I had a general manager one time said, we're in the business of managing risks, not avoiding risks. The least risk program is also a boring one, but you also don't want to take moonshots on everything. So you really want to balance. It's another case of paradoxical mindset. Balance risk-taking with hitting a schedule predictably. So these are the kinds of skills that really differentiate as systems engineering leaders like 10 to 15 years into your career. And I'm going to talk more about these, the decision-making, stakeholder management, and barrier breaking. So I put together a very simple systems engineering competency model. I started with the NASA handbook and the NASA lifecycle. I kind of simplified it, that they had scope and requirements management separated. And I actually agree with those being different. But in reality, on the size of programs that we typically implemented, the people who did one typically did the other. Same thing, the architecture and the design, those were typically the same people. So you have the upfront design, you have implementation. So managing the subsystems actually do this, the implementation of what the design asks them to do, and you integrate it such that you find your defects early. And then you manage all the life cycle, the serviceability, manufacturability, disposability, all the ilities. And then leadership we talked about. And obviously there's the interpersonal skills. This was developed at GE Healthcare, so I just picked from our existing leadership skill set and I simplified it. What you'll notice here is I put down at the bottom critical thinking as a technical skill. For executives, for other functional engineers, critical thinking is important. But as I mentioned, since we deliver instructions and designs to other engineers, framing decisions, taking vague things from product management and marketing, and turning them into clearer problems for functions to solve, I consider that a core technical excellence of systems engineering.